This is day 7, properties of logarithms. We have to use these properties in order to solve some of the equations you're going to see with these logarithmic equations and exponential equations. First of all, you have the product property of logarithms, and that is simply that whenever you see two logarithms being added together, you will multiply the objects of the logarithms. So you can see an example of here that log base 2 of 5 plus log base 2 of 6 is equal to log base 2 of 5 times 6. And what that goes back to is you added the exponents when you were multiplying the bases, and that's the reason for these properties. They line up with your exponent properties. Down here you see the quotient property that whenever you're taking a difference, you will divide. That's because when you divided bases, you took the difference of the exponents. And here you have the power property. That is simply that if you have a power on a logarithm, you can move it to the front to multiply it. When you have a power to a power you multiply, that's where that property is coming from. At the end of the day, you always want to condense these when you're solving equations. So we're going to be from what you see on the left, what you see on the right, to what you see on the left here to condense them to make these problems easier. Alright, example 1 is really a review of the previous day. You're not going to use your logarithmic properties here on this one because you only have a single logarithm here. They are giving you a pH factor to plug in for pH, which is 5.5. So I'm going to have 5.5 equal to the logarithm with a base of 10 of 1 over H plus, hydrogen ions being H plus. Now we're finding the amount of hydrogen in a liter here, and they gave us the 5.5. To solve for H plus, I'm actually going to have to change forms here, as this is in the logarithm and I can't really do anything with it. So I'm going to put a base of 10 on both sides so that that will cancel out on the right. And I'm left with 1 over H plus equals 10 to the 5.5. Now what I'll do is I'll actually reciprocate both sides to get this solved for H plus. So that way it will be H plus over 1 now, and that will equal 1 over 10 to the 5.5. That's actually going to be a good answer for me right now. You could type that into your calculator. Now if you type it into your calculator, it's going to spit out scientific notation answer, which would be fine as well. I would accept that. And it would be 3.16 times 10 to the negative 6 power as scientific notation. Or if you typed it in separately, it would be 1 over 316,227 to the nearest unit there. Anyways, either of these answers are fine, and that's how you do it. This is an example of where you have to use the properties of logarithms. Alright, so you might recognize where the x is, and you'll see you'll have to go into exponential form in order to solve this. The problem being, you have multiple logs over here on the left, so we're not going to be able to do it right now. I'm going to be able to condense this logarithm down using our properties of logarithms. The first thing I'm going to do is I'm actually going to deal with this coefficient. Anytime you see a coefficient on a logarithm, make it a power. So it'll be log base 2 of x to the 4th power. Second thing I'm going to do, I'm going to deal with the difference. So whenever I see a difference, when do I subtract exponents? It's when I divide. So I'm going to actually condense this down as a single logarithm, log base 2, of x to the 4th divided by 5. So that difference just became the division there of the two logarithms. Now I can actually change this into exponential form. I'll put a base of 2 on both sides to cancel. And I'll get x to the 4th over 5 equals 125. Now I'm just going to multiply both sides by 5. So 125 times 5 is going to be 625. To undo this 4th power there, you could take the 4th root, or you can raise to the 1/4 power. I like that better. I think you should get used to using reciprocal exponents. Now I'll have x equal to 625 to the 1/4 power, which is 5. Now before you circle that as an answer, look back. X had to be greater than 0. This answer is greater than 0, so I've got a good final answer here. That goes back to what you saw in the previous day's lesson. All right, example 3 is a similar problem. I'm really wanting you to try that on your own before you see me do it. Now that you've hopefully tried it on your own, you'll see me actually give this a shot. X will be to the second power, so moving that coefficient as an exponent. Now this will be log base 7 of 27 times 3 on the right side, which is going to be log base 7 of 81. Again, I multiplied the 27 and the 3 because I saw a sum. Now I can actually use a base of 7 on both sides here. So I'll have x squared equal to 81. All I got to do is take the square root on both sides, so to the 1/2 power. Now, some people might be sitting there like, aren't you supposed to take the plus or minus root in situations like this? You are correct. The downside here is that only one of those two answers actually works because the logarithm was of x. So it's actually only the positive 9 works here. The negative 9 would be an extraneous solution. Same for the previous problem. Whenever we went to the fourth root, even time you're doing an even power root, you got to watch out for a negative answer. It's not a guarantee that those won't work in the equation, so you really got to look in context of the situation. All right, and here's our last one of the lesson. I'm actually going to condense that down on the left. So it's going to be a logarithm with a base of 6 of, we're going to multiply the x and the x plus 5 together, equals 2. Personally, I like the idea of going ahead and writing the logarithm base 6 of x squared plus 5x, and that will equal 2. Okay, now I'm ready to change forms into exponential, so put a base of 6 on both sides, and that's going to become x squared plus 5x equals 6 to the second power on the right hand side. Now I'll get that in the standard form, x squared plus 5x. I know 6 squared is 36, I'll minus that over. Now you can solve this quadratic any old way you please. You could use quadratic formula, you could use completing the square, you could use your graphing calculator, or you could even factor it. That's how I'm going to opt for. That I know it's going to be x plus 9 times x minus 4 is how this would factor. So I'm going to set both those factors equal to 0. So if x plus 9 equals 0, x equals negative 9. Taking a look back up here, if I plug in negative 9 right here, I cannot do that on either of these logarithms. So I'm actually going to cancel that answer out. That's an extraneous solution. If x minus 4 equals 0, x will equal 4. If I look back up here, 4 is positive. It works out here. And if I do 4 plus 5, that's 9. That's also positive. That's going to be okay there. It works in both logarithms. So in the case where there's multiple logarithms, you have to check on all of them to make sure that your conditions are met. So I had an extraneous solution here of negative 9. Don't include that. Just the x equals 4. And now I'm done with the problem. That wraps up the day. Let me know if you got any questions. Thank you.